There is a method that costs nothing. Not $10, not 50, not a bottle, not an additive. Zero. And a single application can reduce, or in many cases, completely stop, oil burning in engines that most mechanics would tell you need a rebuild. Not temporarily, not for a few hundred miles, but by restoring how your engine was designed to operate in the first place. Japanese mechanics have been using this method quietly for decades, and the reason you've never heard of it has nothing to do with whether it works. It works perfectly. In the US and Europe, oil consumption issues lead to $1,500 piston soak services, $3,000 to $6,000 engine rebuilds, or complete engine replacement. Entire service categories exist around one assumption, that once an engine starts burning oil, it's permanent. In Japan, the exact same engines, same piston rings, same tolerances, same materials, routinely go 300,000 miles without burning oil at all. Same engine, different outcome. They didn't fix the engines differently. They didn't use better parts. They used a different approach. And once you understand what that approach is, you'll realize something that makes a lot of modern repair advice look questionable. Oil burning is very often not a mechanical failure. It's a mechanical condition that was allowed to develop. And more importantly, one that can often be reversed. To understand this, we need to go back to the late 1980s. This was the period when Japanese manufacturers like Toyota and Honda began aggressively optimizing engine efficiency. They reduced internal friction, they tightened tolerances, they switched to lower viscosity oils, and one of the most important changes they made was introducing low-tension piston rings. These rings reduce drag inside the engine, improve fuel economy, and reduce wear over long distances. But they come with one critical requirement. They must stay clean. Because unlike older high-tension rings, they don't have the mechanical force to push through carbon deposits. If deposits build up, they don't break through them, they get trapped by them. And this is where the divergence began. In Japan, maintenance and driving patterns adapted to this design. Engines were regularly brought up to full temperature. They were driven under load. They were allowed to operate in the conditions they were engineered for. In Western markets, the opposite happened. Short trips, low RPM driving, constant gentle throttle, conditions that feel safe, but slowly create the exact environment that causes oil burning. Here's what's actually happening inside your engine. At the microscopic level, piston rings sit inside small grooves around the piston. Their job is to seal combustion pressure and scrape excess oil off the cylinder walls. To do that, they need to move freely, expanding, contracting, adjusting with every combustion cycle. But over time, carbon deposits begin forming inside those grooves. From fuel combustion, from oil breakdown, from incomplete burn cycles during low-temperature operation, and slowly, almost invisibly, those deposits start restricting ring movement, until eventually the rings stop moving altogether. Not broken, not worn out, stuck. Once that happens, everything changes. Oil slips past the rings and enters the combustion chamber. Compression begins to drop, blow-by increases, and oil consumption starts rising. At this point, most diagnostic paths lead to the same conclusion: worn engine, rebuild required. But that conclusion assumes the rings have failed. In many cases, they haven't. They're just immobilized. And what Japanese mechanics do next is the part almost nobody in Western workshops will ever show you, because it doesn't involve replacing a single component. If you've made it this far, you already understand more about oil burning than most drivers, and a surprising number of mechanics. Because what comes next challenges one of the most profitable assumptions in the automotive service industry. Oil consumption is a recurring revenue model. Engine rebuilds, additives, high mileage oils, frequent service intervals, billions in annual revenue built around managing a problem, not eliminating it, because a stuck piston ring creates repeat business. A restored piston ring eliminates it. Look at most oil consumption solutions sold today. Engine flushes, additives, special oil blends. They all attempt to remove carbon, but they do it slowly, diluted, indirectly, and often not effectively enough to free a stuck ring. Japanese technicians take a different approach. They don't wait for chemistry to maybe work. They use physics. They force the rings to move again. This is the method. And it costs nothing. It's a controlled high-load, high-temperature cycle. Older mechanics had a simpler name for it, an Italian tune-up. Here is exactly how it's done. First, fully warm up your engine. Not just coolant temperature. Oil temperature needs to be at full operating range. This usually takes longer than most people think. Second, get onto an open road or highway where you can drive consistently. Hold your engine between 3,000 and 4,000 RPM. Sustain that range for 10 to 20 minutes. Not aggressive, not red line, but enough load to increase combustion pressure and internal temperature. Third, repeat this cycle over several drives. 2 to 3 sessions is typically enough to see noticeable results. Here's what actually happens inside your engine when you do this. At higher temperatures, carbon deposits begin to soften. At higher cylinder pressure, the piston rings are forced outward against the cylinder walls. This combination of heat and pressure begins to break the carbon's grip inside the ring grooves. And gradually, the rings begin to move again. Once movement is restored, oil scraping improves, compression stabilizes, blow-by decreases, and in many cases, oil consumption drops significantly, sometimes dramatically. You are not masking the problem. You are reversing the condition that caused it. Taxi fleets in Japan have been using variations of this approach for decades. Engines that begin showing early oil consumption are not immediately disassembled. They are driven under controlled load, properly, and many return to normal operating behavior within weeks. Meanwhile, identical engines in Western markets are diagnosed for teardown. Now, this is important. This method will not fix a physically damaged engine. It will not repair broken piston rings. It will not reverse severe cylinder wall wear. But those cases are far less common than most people think. Most oil-burning engines are not mechanically destroyed. They are carbon-locked. Your engine wasn't designed to fail at 100,000 miles. It was designed to operate under a range of conditions that most modern driving habits never reach. Short trips, cold starts, low RPM commuting. Over time, those conditions don't protect your engine. They slowly disable it. Japanese engineers didn't design a different engine. They assumed a different usage pattern. And that assumption is the entire difference between an engine that burns oil and one that doesn't. If this changed how you think about oil consumption, share this with someone who's about to spend thousands fixing a problem that might not exist.